Hi. Within the first part of this quick presentation, we will collectively focus on providing an evaluation and an analysis of the historical factors that led to the fourth industrial revolution, known as Industry 4.0. In order to achieve this, we will investigate the factors leading to the fourth industrial revolution and the characteristics of a smart factory, and include an evaluation and an analysis. That's what I just said.
Emerging technologies. Throughout the industry revolution, there's been many technology changes that have emerged, starting with water and steam within the first industry revolution, through to power machines that were able to aid workers, through to electrical machines, and then efficiencies that helped manufacturing evolve. There was also communication from paper and pen to mobile technologies onto fully automated machines that have replaced operators and to operate just-in-time manufacturing. Also portable and wireless devices that have helped emerge and evolve manufacturing throughout the years. Technologies and progressive development within the field of competitive analysis.
So communications, the industry had to find more efficient ways to communicate within organisations in order to stay competitive with the opposition. Reducing waste, driving down defects, speeding up and improving manufacturing processes. During the stages of the Industrial Revolution, good transparent communication was key for this by feeding back information on process quality outputs back into the production lines via area managers, then to team leaders, enabling them to make improvements. Leading up to the Industry 4.0, these manual communication loops soon evolved into real-time data reports of production performance, instantly sending back the relevant information to production areas. This was via wireline connections and then onto wireless remote connections that we use today. Currently, the world's biggest companies are all focused on data as a way to move forward and optimise performance.
The basic principles of Industry 4.0 is that connecting machines, workpieces and systems, businesses are creating intelligent networks along the entire value chain that can control each other autonomously. Failure for companies to adopt some of these practices of Industry 4.0 can risk their competitive edge and marketplace standing. Business has changed considerably since the beginning of the Industrial Revolution, with the days of manually moving plant and equipment around to automated assembly lines and autonomous robots. The UK has moved away from basic rudimentary manufacturing and farming to now being responsible for high-end and precision engineering and manufacturing as a result of embracing all the benefits possible from the four separate industrial revolutions. Industry has changed from a micro buying and manufacturing and having to shop locally to a macro environment where things can be sourced on the globalised around the world.
Transportation and characteristics of Industry 4.0. So in Industry 1, it was reliant on horse and cart and animal labour, through to steam turbine engines where down canals and shipping methods were used, onto steam engines in the railways. Going forward from that, it was internal combustion engine where obviously cars and trucks were then used, followed by aeroplanes to ship material across land and sea. Going forward into Industry 4.0 is autonomous electronic trucks and driving themselves. Going forward from that is obviously smart motorways and tracking vehicles when transportation really kicks into Industry 4.0 in a digital age.
The resources used for energy during Industry Revolution made a huge impact historically. It sparked a revolution that could change the world both technology and environmentally, although the impact of the revolution wouldn't be realised until decades later. They pushed the world forward in terms of production and distribution. Only a few energy resources were used to start the replace of manual labour energies. like fossil fuels replace woods, energy sources used as a primarily for the manufacturer as wood become hard to come by. Coal was able to create a high level of heat, which become more efficient. With the impact of the revolution, improvements of production and technologies, we have been able to discover new renewable resources like electricity, turbines, solar power. These energy resources have become much more cheaper and readily available and are able to keep production operations open for 24 hours.
Science. From 1750 to around the 1850s saw a productive time of intense research and innovation in almost every field of science and technology. The latter period was predominantly productive in accepting, using and innovating technologies in areas such as electricity, industrial engineering, railways, steamships and telephone communications, to name some of the multiple innovative routes taken. More modern physical science is typically concerned with numbers, the measurement of quantities and the detection of the exact relationship between different measurements, assisting in the use of big data in smart factories used today.
So before the 19th and 20th century, iron, steel, wood and leather was commonly used in the first and second industrial revolutions. The first commercial car was built in 1885, made from steel tubing. Driver's compartments created of wood panels, and in 1912 the US Metal Company fabricated its first steel car, resulting in manufacturing over 70,000 cars. As the industry grew, they began to explore lighter metals, new alloys, products such as plastics, and overall these new materials are lighter, stronger and recyclable. Experiments within lightweight materials during the First World War, when an American automotive manufacturer introduced cast aluminium. In 2013, BMW manufactured the first electric car with the first body made of carbon fibre composites. So as we go forward, we can look at graphene, has a tremendous amount of composites and coatings to make it light, strong and safe, with being over 200 times stronger than steel. 97% transparent, extremely light and conducts electricity and heat. However, raw materials such as wood and leather are still commonly used today within the industry.
So geography. So in industry 1, so the manufacturing starts off in just small villages and single manufacturing, went into towns, and then factories were built in industry industry 2. And then obviously as the industries grew and technologies developed, it went to an international level where the trading between world trading could be done, to now it is global connections around the world. So the geography has grown massively for Industry 4.0.
Touching on what Jamie said, geography has quite a large impact on the social side of people's lives. Like he touched on, farming was a big part of Industry 1.0, and obviously people live in rural areas. They then moved to cities. Now with Industry 4.0, people can access stuff from all across the world, meaning that we now might get migration away from the cities, so the population gets more spread out as we go along, which obviously has a social impact. With the rise of Industry 4.0, it led to an increase of workers fearing that technology will take over their jobs. In a recent survey by the Harrison Centre for Social Mobility, 2,000 UK workers were questioned, and 29% of workers were worried technology meant they would lose their jobs. 34% of 18 to 24-year-olds thought this, and 38% of workers aged 25 to 34. So this shows that the younger generation, which are further from retirement, are the most concerned. The change towards this industrial revolution also means educational practices must be moving with the times and providing young people with the skills they require to work in an Industry 4.0 world, a heaven for cyber physical systems.
Each industrial revolution has generated a powerful force for social change, increasing material wealth and quality of life of the workers all over the UK. Before and during the first industrial revolution, money was made through land and agriculture, which was inherited or pillaged, and therefore wealth rarely increased but sustained. During and therefore after the second industrial revolution, wealth could be created through techniques, ideas, inventions and automation, which opened up the industrial world for all to claim their true value. With developments in wealth also came the introduction of legislation such as the Combination Act 1799, which included child labour laws, and the Public Health Act 1848, which was the first step to improve public health. Education also began to change, with charity schools on the rise for poor children between the ages of 7 to 11, and a change in the apprenticeship system, meaning less restrictions, providing more opportunities for families.
So, workforce. With each evolution of the Industrial Revolution, the impact on the workforce within the industry, whether they had to learn new skills in order to support new technologies and techniques that were being introduced. With the introduction of each Industrial Revolution, job types have changed over the years and continue to do so. It is expected that more than 65% of children entering into education today will end up working in completely new types of jobs that currently do not exist, and when they enter into the workplace in 15 years or so time. We need to identify the areas where the big technological transformations are going to be within the industry and equip the workforce for the future. The most effective education is likely to include competency-based multimedia instruction using cooperative work learning assignments and courseware with simulations of real-life manufacturing situations.
So skills, Industry 1.0, it was mainly reliant on 100% craftsmanship, and so unique products were developed and designed. Into Industry 2, where it was a requirement for production skills as the factories were built and mass production was produced. Really into machinery operating skills, into Industry 3, using computers and machines to operate the production, and into Industry 4, which is mainly reliant on digital skills, and workforce needed to be upskilled to gain qualifications to run the production.
So as efficiency continued to improve throughout the industrial revolutions, the introduction of steam engines and new machines that increase efficiency, the transition from production methods to machine, and the development of machine tools gave rise to the mechanicalised factory systems. So this introduced mass production, enabled large volumes of products to be manufactured in efficiency processes. So this reduced the cost of labour, the overall price of the products. The assembly line increased efficiency in the manufacturing process, and this was obviously rolled out worldwide. So the use of computers got introduced, and this was able to collect data, which eliminated waste within the manufacturing processes.
Change management. This is a term that's used to all approaches to preparing and supporting organisations in making organisational change. These changes occur as companies try and better themselves and become as successful as they can be. With industries becoming very competitive and new technology becoming available throughout the different industrial revolutions, it's important that changes are managed efficiently. With previous industrial revolutions, change management has been done through the use of several different methods, such as the use of the LO1 or the McKinsey models. As technology now improves, change management is becoming more digitalised. This means that new methods have become available, and it's allowing for change to be focused on being fast and being continuous rather than being individuals doing it exclusively. This includes all employees across the business introducing changes. The new technology and methods have been deemed the Bible in leading the fourth industrial revolution successfully.
Connectivity has evolved over the Industrial Revolution for human intervention to networking through basic communications, to phones to emails, even face-to-face connectivity via devices. This has had impacts on the way manufacturing production is undertaken. With the evolution of technology, machines are able to connect to softwares and systems that help run manufacturing operations and make quicker decisions, and store and collect big data that requires, again, to make quicker changes within the industries. Connectivity within manufacturing processes is not new, yet recent trends have set the rise of the fourth industrial revolution of the digital and physical worlds, including information technologies and operation technologies. These are made the transformation in supply chains and increasing possibilities of smarter factories, representing a leap forward in traditional automation and fully connectivity flexible systems.
Industry 4.0 is reshaping the way we work, whether it be the introduction of connected machinery, performing the process, for example, the technology used in farming to scan the crop and highlight when it's ready to harvest. Even the harvesting is aided by robotics and automation, to the ability to remove, to the ability of remote working, giving flexibilities to employees. In fact, according to CIO, 89% of employers with flexible working options are said flexible working options are very important in terms of staff attraction. Businesses are using technologies to show daily their flexibility that they're showing.
As touched upon above, the purpose of Industry 4.0 is to connect the entire value chain together to yield efficiencies and optimisations within the manufacturing process. Mr. Kettle, on his return from the 2019 Hanover Trade Conference, noted that there was an unprecedented shift in the focus of manufacturers to push the internet and the general connectivity brought within Industry 4.0 to their machinery and production environments. In turn, and through the use of data analytics, it is possible to effectively scale a business in line with demands of the market, the movements of the market, and the customer preferences. However, this in itself brings with it a host of challenges and obstacles which must be overcome in order to succeed. In order to truly embrace Industry 4.0 in line with scalability, a substantial IT network will be required, along with the robust security protocols, which of course comes at a cost. With massive scale, the only way to truly flourish is with automation.
With business requirements constantly shifting throughout the revolutions, the need for employees and businesses to become more agile is getting more and more important. With elements rapidly changing from Industry 1.0 to 4.0, both the business and its employees need to be able to respond to these changes and quickly. They need to be able to do this efficiently and without losing momentum. As we moved into the third industrial revolution, for example, automation was introduced. The workforce and business needs to be adaptable and flexible so that the new processes being used were used efficiently. As we now lead into the fourth industrial revolution, connectivity becomes a key. So again, the business and more so the employees need to be able to adapt to these changes quickly, therefore showing good signs of agility.
So as previously mentioned above in the last slide, the characteristics of regarding efficiency can be identified through the connection of departments sharing information. This could be real data enabling collaboration with suppliers and customers, the use of internet connections between machines and rundown times obviously reduces the maintenance and changes within production. The use of autonomous vehicles and robots will adjust automatically to production needs and orders that come in through the system. The ability to obviously be proactive to identify defects within the manufacturing process from data shared and as continuous improvements through data collection, obviously again enabling efficiency throughout the process.
So autonomy, in Industry 4.0, autonomy is such things like the cars parking themselves. You're not really in control of the process, so you're very reliant on the technology doing what it should be doing. In terms of Industry 1, you was very much in control of the craftsmanship. You were making something yourself, so therefore you were in control of your own outcomes. So the judgment had to be made of mass production in terms of autonomy. and being in control of them machines and getting them to produce what they need to produce.
Data analytics. The analysis of data is only possible if the data itself has been captured. With a movement towards increased automation and robotics, it is infinitely easier to capture, record and process a huge amount of data available, with the results being almost instantaneously available. This information can lead to an increase in knowledge, insight, along with any other form of data-driven intelligence in order to gain a better understanding of the bigger picture. Ultimately, this helps to focus on an organisation's efforts and achieve the desired strategic aims and goals. Andy Rowland, the head of customer innovation for BT, claims that only 3% of industrial data is currently used in a meaningful way, meaning that 97% of all data derived is currently going unused. This data isn't just derived from customers, but also from equipment and machinery itself. Subsequent analysis could help identify the optimum scheduling of preventative maintenance to avoid breakdowns and stoppages, as well as data related to streamlining production processes, optimizations and scalability as previously discussed.
So forecasting, so the prediction the needs of the future of the business established from data. So orders are automatically prepared and released to suppliers, and production orders, are given to the manufacturing areas. So data collection enables trends to be identified from historical data of market trends. The plan of production can be scheduled well in advance. The collection of the data will enable flexibility, credibility to forecasting, giving an overall improvement to previous industrial revolutions.
As we move through the industrial revolutions, we're collecting more data, we're using more data, and we're analysing more data. Therefore, data visualisation is a key factor in moving towards Industry 4.0. Industry 4.0 is called for business to improve their systems, which they use to analyse and therefore display the data. Within this industry, cognitive machines are used, for example, to self-diagnose and display data, rather than manual labour through previous revolutions. The revolution highlighted in this debate to be shown quickly and in many different forms, depending on the audience. With all employees now being involved in business improvements rather than just management, it's important that all levels can view and understand the data. As businesses continue to improve their efficiency, data is vital in helping reduce any remaining waste. If the data was still visualised in the same way as early industrial revolutions, such as paperwork, the reaction time will be slower to the data as we visualise today, which is displayed instantly on monitors, boards and the internet.
Following this piece of data, within the fourth industrial revolution, quality control has become more autonomous than ever before. Advanced sensor technology, which is built into robotics and machinery, measures and tests products and or parameters whilst running. These measurements also allow for the automatic data collection within the jurisdiction of the machines. Intelligent machines can also adjust themselves for process improvement. This plays a key role in quality control and quality assurance.
So how has the physical support from suppliers changed with Industry 4.0? So as Industry 4.0 has become more prominent, the support from the suppliers, especially machine suppliers, means that they can now support remotely from anywhere in the world instead of having to be at the site of the machine right at the moment when the error horn sounds. Things such as Skype mean that the suppliers can be given instant feedback so they can in turn provide instant support. This remote service does, however, have its risks, as service can be hacked from anywhere in the world to cause disruption to a production environment. This support also involves a new breed of technical knowledge that's required, from mechanical knowledge to programmable knowledge.
So for the decision-making support, to support decision-making within the factory, the smart factory era, we now have facilities such as digital twins, which are virtual equivalents of physical assets and processes within the manufacturing environment. These enable the product quality monitoring system that can show us predicted production performance before the product is released into the market. Government regulations and industrial organisations also help support and sometimes influence decisions for the industry during transitional stages of industrial revolution. Okay, to summarise, key milestones in the evolution of industry have progressed from the first industrial revolution using steam, mechanical production equipment, to the use of electricity and division of labour for mass production assembly lines in the second revolution. In the third came digital technology and the use of automation using computers, then evolved more towards where we are today with Industry 4.0, introduced in artificial intelligence technologies, increased computer power and data to support production networks, the Internet of Things and more advanced cyber physical systems. Here we've completed an exercise using spaghetti diagram to do a group analysis for the key historical factors that have contributed to industrial revolutions leading up to Industry 4.0 compliant smart factories. So we've looked at some of the key factors like energy, transportation, workforce and materials, and how they've evolved through history to get to the smart factory 4.0 compliant. So where we've moved from, for example, coal energy, we've gone from coal to oil to natural gas, nuclear, and then into electronics, transistor, microprocessors, and telecoms and green energy that all evolve into digital, connected, autonomous, data-driven and flexible that we have in 4.0. So we spoke about the characteristics of the smart factory. These all come together to form an optimised, transparent and proactive operation which makes for an efficient manufacturing environment.